All right. Figure out who has the most letters in their first and last name combined. Okay, whoever has the most letters combined in their first and last name, you are the speaker for today of your group. Okay, you are the speaker for your group. Okay. All right, so pod 8, whoever your speaker is, pod 8. Okay, what does this graph look like?
It's a parabola, and then it goes below the origin. It's
Okay.
It's over a little bit to the left, and then it's down.
Where does it hit the x-axis? Maybe that would be an easier way to describe.
That's It's at -3 and 2.
Okay. Thank you. Okay. Pod number 2. When is f of x greater than 0?
You said that when it starts, like when it crosses like the y-axis at 0 and then it just goes up. We weren't really sure.
Okay. Let's talk about what does f of x stand for in our graph.
Like the function itself.
Which values? I guess maybe I should rephrase that. Which values does f of x stand for? The y values. So I'm asking for when is y greater than 0, right? When is y greater than 0? So what kind of values are greater than 0?
Positive.
Positive. So this is asking for when y is
Positive.
okay. And what would we need to look for on our picture in order to do that? Like y is positive.
X-intercepts.
Okay, x-intercepts would be good. So would we look above that or below that?
Above.
Above that, okay. Y is going to be positive above the x-axis. Do you agree? Okay. So in interval notation, pod 5, interval notation, where do we have positive y values?
I had negative infinity, held on 3, or negative 3, sorry. And then 2 commas.
Brackets or parentheses here. Okay. Negative infinity to negative 3 and 2 to infinity. Pod 4, why did pod 5 give us parentheses and not brackets? We don't need to include. I only said greater than. Okay. So my speaker from pod 6. Yes. What are the most critical points when we had to look at what our answer was? Like, what was the separation? The x-intercepts. And why were those so important, Gabe?
Because those are what tell us zeros, and it's going to go through that.
Okay, that's what's separating positive from negative, right? Our x-intercepts. Okay? Today we are going to be solving inequalities that are not linear. So you solved linear inequalities way back in Algebra 1, right? And you've been solving them forever. I think those are fun, right? I think in Algebra 2, you may have solved some inequalities that dealt with absolute values, okay? Well, now we're going to be doing some that deal with polynomials and rationals, okay? So, you kind of did that without me having to tell you what to do, okay? Now, do you get to graph with your graphing calculator on the test on Friday? No, so let's talk about how we're going to determine what our intervals are if we don't actually have the graph, okay? So here we go. To solve a nonlinear inequality, the first thing we need to figure out are the x-intercepts. Okay? Like Pod 6 told us, the x-intercepts are going to separate where y is positive from where y is negative. Okay? So if we can find those x-intercepts, we'll at least have an idea of where the separation could occur. Okay. From there, instead of having to graph it, I mean, you could graph it. You don't have to graph it. Instead of graphing it, we can test our intervals. In between our x-intercepts, our graph is going to have to be above or below the x-axis. So if we just test some numbers to see if we have positive or negative y values, we can figure that out without having to graph it. And I'll show you what I mean by that. This is what I mean by that. Okay, sorry, I forgot I had this up here. When we test an interval, we're literally just going to put an x value into our function in between our x-intercepts to see whether it's above or below the x-axis. Okay. And then from there, we'll be able to represent our answer, and we're going to do that in a couple different ways. So we're going to represent our answer. I already showed you one way, essentially, that we're going to represent our answer, and that's using interval notation. But then I'm also going to show you how to represent it on a number line, okay? Because we're essentially going to use a number line to test our intervals. So we can write our answer on a number line as well. Okay, so if we have a polynomial inequality, do we know how to find zeros? That's what we've been doing like this whole chapter, right? Finding zeros, okay? Hopefully we'll be able to just factor it, but if we can't, we do have that rational zeros test that we can use, okay? Once we find the zeros, it's as simple as putting it on a number line to test values, okay? We ready? Please write this down. Okay. My first comment to you is that we need to compare to 0 so that we can find our zeros and use our x-intercepts to figure out our inequality, okay? So I don't want you to leave it like this. And maybe if you need to make a note to yourself to compare to 0 first, that might be a good idea. Okay. But in this inequality, I need us to write it as x cubed minus 4x squared minus x plus 4 is less than or equal to 0. That's the inequality that we are going to work with. Okay, so if we're gonna find the zeros, how would you suggest doing that?
Factor.
We can factor it, and what would our method of factoring be?
Grouping.
Grouping. Okay, so first of all, I am going to set it equal to 0 to find the zeros so that we don't have to mess with the inequality sign. Okay, we'll come back to the inequality, but let's go ahead and do our work. Set equal to 0. So I'm going to factor an x squared out of the first two terms. Out of the second two terms, there's not really anything in common, but if we want x minus 4 right here, what would we need to factor out? We would need to factor out a negative 1. Okay, so x minus 4 is in common. Left over is x squared minus 1. And we know that x squared minus 1 can factor to x plus 1 and x minus 1. Okay, now we need to test our values. Okay, so what we're going to do is we're going to put our zeros on a number line here. Okay, essentially, we're just going to think about the x-axis here. Here's the x-axis. Here is positive 1. Here is negative 1. And here is 4. I'm going to scroll down so you can see our inequality that's set to 0. What we need to do at this point is test our intervals. So right here, these are our, here I'll highlight them in green. These are our zeros. We need to figure out, are the values in between above or below the x-axis, okay? And we can do that by plugging in numbers. So I'll show my work. You don't necessarily have to, but what would be a nice number to plug in that is less than negative 1? Negative 2 would be an excellent choice. And if we plug in negative 2, negative 2 cubed is negative 8. Minus 4 times negative 2 squared, we would have negative 8 minus 16 plus 2 plus 4. I don't really care what the value is, but is it positive or is it negative? Negative 8 minus 16 plus 2 plus 4. That's going to be negative, isn't it? Well, is that less than or equal to 0? It sure is. So this works, which means anything below negative 1 is going to work in our interval. Between negative 1 and 0, what would be a good number to choose? Oh, dang it, I just said the answer that I wanted you to say. Between negative 1 and 1, what do you think would be a good one to pick? I was so excited about plugging in 0. When we plug in 0, we get a positive 4. Is that less than or equal to 0? That does not work in our interval. So between negative 1 and 1, we're not where we want to be. Those values are above the x-axis, not below. Okay? Between 1 and 4, what do you want to pick? 2. The smaller the number, the better, right? And on the positive side of things. So let's just think about, is this number going to be positive or is it going to be negative? Okay? We would have 8 minus 16 minus 2 plus 4. That's going to be negative, which means it works. So anything between 1 and 4 will also be negative. Last interval to test would be after 4. So we can plug in 5. 5 cubed is 125. Minus 4 times 50. 4 times 25. I don't know why I said 50. So we have 125 minus 4 times 25. We're going to have a positive number, aren't we? And we want our numbers to be less than or equal to 0, so that doesn't work. Okay? So here of the 4 different chunks, we have 2 intervals that work. And since we have equality here, we better put brackets on the end of our interval. There's your number line answer. It's essentially your interval notation colored in on a number line. Okay. In interval notation, we would write negative infinity to negative 1, 1 to 4. Is anyone curious about what the graph looks like? A little bit? We know what the graph looks like, right? Do I ask you to graph polynomials without your calculator? Yeah. Let's talk about how we do that. I tell you to plot your zeros. Okay. Our ending behavior, we have a positive leading coefficient, a degree, and our multiplicity is odd for each of those. We have 1 multiplicity for each of our zeros. Okay, so let's look at our intervals. Here, we're below the x-axis. Here, we're below the x-axis. That is what they were asking for. Questions? Okay. Let's take it up a notch. What other kind of graphs have we been working on? You just did a worksheet on it. The rational graphs. Okay? So let's talk about this rational inequality. Here's the inequality, here's the graph. If I'm asking for when that inequality is greater than 0, have a conversation at your pod. Where is this graph greater than 0? Talk about it. All right. My speaker from pod 1. Where are we greater than 0?
When it's less than 5 and greater than 2.
When x is greater than 2, I heard greater than 2, so like 2 to infinity. And what was the other place you said?
Less infinity, -5.
Are you talking about like this right here?
Yes.
Okay. So less than -5. So less than -5, but greater than 2. Right? That's what you described to me. I just converted it to interval notation for you. Okay? All right. Do you agree with pod 1?
Well,
Okay. Now, I see this -5 here. That was important, right? -5 we consider a 0, so that was important. Something else was important about that graph. Talk about it at your pods real quick. What else is important to consider besides the x-intercepts for this rational graph? And be specific. Be specific. I hear some answers, but be specific. Okay. All right. Pod 3. What else is important? Which one? Both of them? Or just one of them? Ah, the vertical asymptote. Notice how this vertical asymptote here separates this graph from being like decrease or below the horizontal asymptote, above the horizontal asymptote, right? We have the opposite behavior. So your vertical asymptote would be one more spot to consider if you have a rational inequality. So I want you to come back to this over here. Find the zeros. Also, write in vertical asymptotes, because those will also be considered critical. Okay? They could separate your graph from being above versus below. Okay? Now, polynomials, their graphs are pretty quick to think about. Not necessarily rational graphs. So our method of testing intervals will be really important for our rational inequality. Please write this down. What was that first thing I told you to write in before finds the critical points? Ah, set to 0. Is this? Is this set to 0? It is not. Okay. So, we need to actually subtract that 3 over. I asked you to graph this right now. Could you? Is that something that we've graphed before? Not really. We haven't had that floating -3, have we? Okay, we've only dealt with one fraction. So let's make this one fraction. How do we do that? What did you say? A common denominator. The denominator right here is x minus 5. If we want to actually combine these two together, they both need a denominator of x minus 5. So I'm going to multiply 3 by x minus 5 over x minus 5. Okay? So what we are working with is 2x minus 7 over x minus 5. And we're subtracting 3x minus 15 over x minus 5. Okay, so what happens? X minus 5 is our denominator. We have 2x minus 3x, and we have negative 7 minus negative 15. We do have to subtract that through. Now we have one fraction compared to 0. Okay, two things we need to identify. The first is our 0. We talked about intercepts, x-intercepts yesterday. What did I tell you to look at? What did I tell you to look at and set equal to 0 to identify an x-intercept? The numerator. So Addie, what number makes my numerator 0? Okay, 8 makes our numerator 0. That is our x-intercept. Okay. Our vertical asymptote. Pod 7. Who's my representative from Pod 7? Nate, where's our vertical asymptote?
5.
5. Okay, so at 5 and 8 we have critical values. Okay, now we need to test it. We're looking for where our values are less than or equal to 0. Guy, give me a number less than 5.
4.
Sure.
You're really good.
Negative 4 plus 8 is a positive number, divided by 4 minus 5. That's a negative number. Positive divided by negative is negative. Do you see how I didn't even care about what the value was? I only care about positive, negative. Okay. Aaliyah, give me a number between 5 and 8. 6 sounds wonderful. Negative 6 plus 8 is positive. 6 minus 5 is positive. A positive divided by a positive is a positive. That is not what I'm looking for because our inequality says less than or equal to 0. Sydney, give me a number bigger than 8.
9.
Negative 9 plus 8 is a negative number. 9 minus 5 is a positive number. Negative divided by a positive is a negative. That works. Conversation at your pod. Do I put a bracket on 5 and a bracket on 8? Please just guess. All right. Pod 2, what was your discussion?
We said do not put a bracket on the 5, but do put a bracket on the 8.
Okay, so the bracket, yes for 8, but no on 5. Okay. Pod 7, so Nate, why would 5 not get a bracket? What makes you suspicious about 5?
Because it's the vertical asymptote.
It's the vertical asymptote. Can we have a value on the vertical asymptote? No. Your vertical asymptote always has to have a parentheses on it because it can never be included. There will not be a value there. Okay, so here is kind of a weird one. We had the equality. So at 8, we got to put the bracket, but our vertical asymptote will never get a bracket. Okay, so negative infinity to 5 and 8 to infinity, where only 8 has the bracket to include. All right, this is what I need from you. We have 10 minutes. Have at least one book open at the table. I want to see if you can get through 1, maybe even 2 homework problems before the bell rings. Okay?